Good.
Doubling up. Roger roll, Atlantic.
Water towers fly!
Echo Delta nominal.
Flight down feed off. Bring in, feed off.
Yikes. You bet. Okay. We don't need any more of these.
All right, y'all. It's time to get another show going here. You know the drill. Give me some 5x5s in chat. Let me know if you can see and hear me. John Galloway for NASA Spaceflight. Today, going to do a little bit NSF Live / Astro Live with Intrepid Museum, talking robotics that go to space. Space robotics, I guess we could say. Let me make sure I got a ton of 5x5s in chat. Already almost 1,000 people watching, so we will get going here. Like I said, we've got a really cool show happening today. We've got a mission controller from the Canadian Space Agency who controls Canadarm 2, and we've got an engineer, a very skilled engineer who's worked on multiple different robotic arms, most recently the European robotic arm and all sorts of other cool projects. We've also got our friend Summer Ash, who will be here in just a second. But before we get started, remember, these streams don't just happen, they're made possible through a grant awarded by the New York Space Grant Consortium. Always happens that way. Also, we keep doing these streams because y'all keep showing up. We really do appreciate y'all showing up for the shows. Again, if you're just joining us, you haven't seen one of these before, this is live. And it's a Q&A. You're going to be able to ask questions from chat to the engineers, the controllers that we're going to have on here today. If you do have questions, tag us in chat. All the different streams that we're going to, you can put NASA Spaceflight. You can put, yes, it's not my Robot Garage extension. I saw that over there. No, these are much more complicated robots than anything I've ever worked with. You could put question. If you're watching over on Twitch, if you're on Facebook, just type your question into chat. Wherever you're watching, over the course of the show, feel free to ask us questions. Keep them on topic. Keep them relevant to what we're talking about here. Robotics and space and controlling of the arms and all that sort of stuff. But if you ask some cool questions, I will ask them. Also, be patient. If you ask a question and it takes us a little time to get to it, as soon as I see it in chat, I'm going to be like, stop everything. I have a question to ask. It does take me some time to work the question in on occasion. And if I miss your question, it doesn't mean that I don't like your question. We just always have so many great questions and we don't have enough time to ask them all. So without further ado, let's go ahead and hop on in here. If I can locate my mouse, there we go. And let's introduce our special guests today. Summer is here, Danielle is here, and Vinita is here. Summer, you want to go ahead and start talking about our special guests?
I will absolutely start talking about our special guests.
All right, let's get some introductions going.
I am thrilled today because we have two amazing women working in robotics in space. So we are joined today by Danielle Cormier from the Canadian Space Agency. She's a flight controller for the robotic systems on ISS, and she's part of the Canadian members of the NASA group responsible for planning and execution of all of the ISS robotic activities. And we're also joined by Vinita Madill, who is a space engineer and founder of the global platform Rocket Women. And she aims to inspire women in the field of science and technology. And she's former European Space Agency robotic arm engineer. And she is also helped design the skin suit and conducted studies on future spacesuit design for lunar exploration. So welcome, both Danielle and Vinita. It's so exciting to talk to you today.
Thank you. Thanks for having us.
So just because you're incredible women and you're working in this robotics, this highly technical field, I would love to find out more just about how you first got interested in science and technology and engineering, and then how you actually got to your current position. So Danielle, would you like to start?
Well, how I got started a long time ago when I was about 5 years old when my first book was an astronomy book, and I fell in love with it to the point where I told my mom that one day I would work at NASA. So that was always the dream. So yeah, I've always wanted to do this. I even went to, Space Camp, Space Academy when I was a teenager. I taught at Space Camp Canada when I was in college. So that's always been, the dream. And when I got the opportunity to go to a co-op tour at the Canadian Space Agency, I took it and I never left. So.
And what about robotics specifically? So you first got interested with astronomy, but then what got you into robotics?
Well, robotics, I think it basically it was what Canada was doing, right? So I fell in love with it, but it really, it is what Canada really does in space when it comes to human space flight. So that was a really cool opportunity.
Cool. And what about you, Vinita?
Yeah, so I've always been interested in space since I was young, like Danielle. So I was around the same age, I think around 5 or 6. And I was inspired by Helen Sharman, and she's the first British astronaut. So I remember going to the library with my mum and seeing an image of her in a book. And there was a woman in a spacesuit with a British flag on the arm. And I've been used to seeing NASA astronauts on TV on space shuttle missions. And I'd never really seen somebody that from the UK, where I'm from. And I think really seeing her showed me that my dreams are possible and I could be an astronaut if I wanted to. And she really became a role model to me and kind of was my impetus along my journey. And so then I knew I wanted to be an astronaut. So I printed the NASA astronaut guidelines and I put them in my high school folder, and you needed a STEM degree. So I ended up doing maths and physics with astrophysics. And I knew I wanted to do space, but I didn't really know how to get into the space industry. And it was through that and at a conference, through the UK SEDS conference, which is the Students for the Exploration and Development of Space, which is a great organization. I'd recommend anybody getting in touch with if you're interested in getting into the space industry. And I met somebody there from the International Space University. And so I found out about this university that was focused on space, and that sounded like a dream. And so after graduating for my bachelor's degree, I went to do they have a summer program called the Space Studies Program. And I know Danielle has also done the program and also do summer as well. So I think there's a lot of Space University alumni in the space industry as well. And I think it was through ISU that I learned about what the space industry really was about and the breadth of careers that are available in the space industry. So I ended up doing space engineering in the UK. And through that and through an actual internship through the International Space University in the master's program, you have an amazing opportunity to do an internship at the end of this at a global space company or at a space agency. And it was through that I worked on the Skin Seat project originally as an intern, as a trainee, and then consulted on it, and then ended up working on ISS payload operations at the German Aerospace Center, and then eventually on the European Robotic arm at ESA's Technology Center in the Netherlands as well. So it was really that progress, but also just being fortunate to meet these incredible people. And it was actually when I was at the German Aerospace Center, I ended up working with a space operations engineer that I'd met at that careers fair 5 or 6, 7 years ago. And I was actually working directly with him day to day. So it's a very small industry, but also the people in there are incredible and really inspirational too.
Yeah, I promise we will get to robotics, but I forgot. I would love to give a shout out to ISU because all 3 of us have gone there. And even I was mentioning before we even started the show that Danielle and I have a friend in common who was a classmate of mine at ISU. And so obviously we should send this recording to ISU afterwards so that they can see all of their alumni. So Danielle, I grew up, or I'm going to date myself, and with just the Canadarm 1, which didn't have a 1, but it was, with the space shuttle. So did you work on that as well, or did you come on board specifically for Canadarm 2?
I came in specifically for Canadarm 2 in that Canadians really got into being flight controllers with Canadarm 2. But we did join the group at NASA that was in charge of both arms. So really we got to, I personally did only operations for Canadarm 2, but we'd be handing pieces over to Canadarm 1 and back and forth, and our group was integrated. So, and when I was training, since I was part of the first bunch of flight controllers that got certified to operate Canadarm 2, we got to learn from the Canadarm 1 people. So I actually got to sit next to them during shuttle missions while they were operating Canadarm 1 so that we could understand what the job was.
Yeah, and so this is an image in mission control where what kind of things are you doing when you're operating the arm?
So the what we're seeing right now, the rooms, that's the one we actually have here in Canada at the Canadian Space Agency. and it's considered part of Mission Control Houston. It's just a remote part. So what we do is basically we're the ones that do all the planning for all of the maneuvers that we're going to do with the arm. And nowadays, about 98% of the time, it's actually controlled from the ground. So we're actually the ones that send the commands to move the arm. And the astronauts, there's only a couple of things that they still do. Like when we have a cargo vehicle that arrives at space station and needs to be caught by Canadarm2, well, they have quicker reflexes because they're there, whereas we have a certain delay. So there's the ones that get to do that. But once it's caught, we're the ones that actually install that vehicle on space station.
Can I ask what's on the screens here? Like, am I supposed to be zooming in on the screens like this? Like, is this like a list of movements of the arm or something? Like, I'm so curious.
Well, what you're looking at right now is the timeline. You have the cruise timeline, you have the timeline of what's going on the ground. And the other screen, it's like telemetry. It's our applications that we have to actually send commands to space station to move the arm. So it depends on what you're looking at, but it's really what we use to basically operate our systems.
I'm so curious. Like, I expect when you're working on the things, you have like all these cameras that are all over the arm, and you see all these different directions, and you're there with a joystick, like playing it like a video game. And I assume it doesn't actually work that way, does it?
No, the astronauts have joysticks. We don't. What we send is coordinates. So it's all pre-planned. We know if we send the arm to this type of coordinate, it's going to move this way, and it's all been verified on the ground, beforehand. So we're not going to hit anything. So it's really just coordinates when we do it from the ground. The astronauts do have joysticks.
It's almost more like playing chess. Like, you're like, Canadarm, move to B3 or whatever, right? And you tell it what to do, and then it does it. You're not there in real time like, go a little to the right or anything.
Exactly. We do have methods of aligning, but again, it's just telling it go 3 centimeters to the right because we think that we need that to align with what we're doing. But it's not, joystick, go there. It's more, we talk within the themes like, I think it's 3 centimeters. Yeah, I agree. And then you type it in. It's like, yes, you entered the right thing, and we agree, and then we're going to send it, and then it's going to move.
And then it's going to do it.
It's not quite as fast.
It's a team effort, it sounds like, huh?
Oh, yeah. Our teams are 3 people, and we all have to agree that we're doing the right thing. So nobody can really mess up in a way that's going to cause really issues. But, yeah, it's a team effort, always a team effort.
It's like robotics checks and balances. Danielle,
Yes.
I was wondering, just to get a sense of like the coolness and the power of the Canadarm too, like what are some of the like working stats of like how big is it? How heavy is it? How fast can it move? Or what? I mean, you're capturing other vehicles, which granted you're in microgravity, but how much is it capable of moving?
Well, I mean, it depends, right? When we move from the ground, we go slower. Like, there's nothing really that pushes us to like do anything really fast. So the arm is 17 meters long, so 51 feet long. So it's quite big, but on the scale of the International Space Station, it's really not. It has 7 different joints. And one of the things that's really cool about Canadarm2, you kind of see it here. It's symmetrical because each end can be either the base or the tip, because it needs to go different places on space station to be able to do different things. So when we need to relocate it, we'll just go and grab a new anchor point, tell it, okay, you're now, yeah, exactly. Say, what was the base? You're now my tip. What was the tip? You're now my base. And just like, we call it a walk-off. So we can just walk to different parts of space station just to get located to where we need to be.
I'm going to expand on that for just a second, because I think a lot of people don't really understand that, right? So I'm going to set up so I can draw, but the Canadarm, it's not like one part of it is the base and then one part of it is the end that has the little grapple on it, right? either end can be the grapple end. And as it moves around the station, it's almost like a backwards inchworm or something like that. I guess it's not really an inchworm, but a lot of people don't understand. Let me see if I can draw in chat. Tell me if you understand what I'm attempting to draw here, okay? So imagine you have like a space station, right? Well, apparently, there you go. That's not a very good space station. Imagine you have the space station. And as you have this, like, you know, there's some main truss, and then these are solar panels over here, and then you have the main part of the station in the middle. All right, I'm not going to draw the whole thing, right? It's a very technical drawing. But as the arm goes around, it has like these little grapple fixtures, right? I'll get a picture of it in a second. In one end of the arm will attach to the grapple fixture, and the other end will be like out here floating around, right? And there's another grapple fixture over here. Maybe there's not. I just made this up. But this end of the arm will actually attach to that fixture. This end of the arm will actually detach, and then it'll start waving around like this, right? And now you can grab stuff with this end of the arm. Whoops, I'm a little bit too high up there. You can grab stuff with this end of the arm while this end is on a fixture. And then you start crawling forward, and there's a grapple fixture up here. So this end of the arm will grab that fixture, and then this end will let go. And all of a sudden, it looks like a very confusing football play. But either end of the arm has the end effector on it, I guess, right? I'm making these hand motions. Either end has the end effector, and either end can grab a fixture, and the other end can do work. And then this end can grab a fixture, and then this end can do work. And a lot of people don't understand that that's how it works. Like, you can literally walk it all over the station, right?
Yeah, and even on top of that, we have what we call the mobile base that has 4 of those anchor points.
Yep.
And that's on the mobile transporter, which is kind of like a train
Yep.
that goes up and down the main truss of space station. So we can like just put Canadarm 2 on it and just go to the other end of station on this train. So we can really just position our robotics wherever we need them.
Yeah, there's like a rail system, like literally a train system that has the little base on it, and that thing can go back and forth, and the Canadarm can Canadarm 2 can sort of ride that back and forth, or it can grab the fixtures and inch around or whatever it needs to do. Like, it's really amazing how much it can move around the station because it's what they use to move things around, right?
Yeah, so Vinita.
Yeah, and we also have our robot Dexter that we can just grab with Canadarm 2 and position it where it needs to be. So it's really a flexible system. We can do all kinds of things with it.
Nice. All right, Summer, back to you. I had to jump in because I've always thought that was so interesting, the way the arm can sort of like inchworm its way around.
Yeah, and that's a much better description than my walking fingers.
It's better than my drawing as well, that's for sure.
Somewhere in between is the right one. Yeah. But so for comparison, Vinita, you worked on the European robotic arm and do that, right?
I did, yes. I actually have a nice little model, so if it's helpful. These are actually really hard to come by. There's only a handful left. They were made maybe 10 years ago. So if you link the project manager for the robotic arm maybe has 4 or 5 left. So I got these on my last day. But this is a model of the arm. So you can see that here. So it has an elbow, 2 wrists, and basically 2 hands. So similar to the Canadarm 2, it has 2 end effectors at the end, and it's around 11.3 meters long, so a little bit smaller than Canadarm 2. And the unique thing about ERA is that it's on the Russian side of the station, technically. So it was launched with MLM, or the NORCA module, event of July 2021, which is amazing. It's been a tale of perseverance. I think the original contract was signed late 90s, so it's been in development for a long time. I think I joined at a very fortunate time. It was near the end and it was close to launch, so we were able to upgrade the arm and also create new payloads and introduce HD cameras to really upgrade it and to create a new arm for the station as well. I guess a few stats to compare it to Canadarm 2. It weighs around just over 600 kilograms, and it can handle payloads about 8,000 kilograms. So it's very powerful, and it can reach up to almost 10 meters, and it's very precise in a few millimeter range as well. And it's made of carbon fiber and aluminium. And you can see it there actually being used on the space station, which is absolutely incredible for everybody that's worked on it over the last decade or so. And it's similar to Canadarm 2, it walks around the station using base points, so similar to handholds, I guess, if you're rock climbing. So kind of hand like base point over base point using the end effectors and grapples and ungrapples. So it actually detaches from one side, kind of similar to walking over the station to perform its tasks. And the difference between Canadarm 2 and ERA is that ERA really brings a new way of operating automated machines to the space station. So we can perform a lot of tasks automatically that are pre-programmed from ground. We've tested the missions that we've developed using a simulator that we have at ESTEC, which is at the ESA Technology Center at the European Space Agency, and also there's one in Russia as well, in Moscow. And it can also be operated from inside the space station or outside. So for ERA, it's not operated from ground at the moment, but it's operated from the station by the crew. But they can also operate it from outside the station. So maybe, I'm not sure if you have a picture of the, they call it the EMI. So it's the EVA operations console where we operate ERA from outside the station. And it's largely kind of ground pre-programmed. So it's an onboard supervised mode of operating, which is fairly new as well for the station as well. And that's something we need when we look to the future as well, which is very exciting. But yeah, so it's amazing to see actually being used on the space station right now, something that you've actually worked on in development. So that's an amazing feeling to have.
Oh yeah, I bet. You bring up a couple good points. One, that there are, the station is huge and there still are some like divisions. So there's obviously the US side and then the Russian side. So the Canadarm 2 is on the US side, and then the ERA is working on the Russian side with a couple other modules, which is a really good point. I guess they probably do technically have a zone of overlap, but there's probably some like agreement that the Canadarm only works up to here, or touches things here, and the ERA only touches things up to here.
So Danielle can jump in.
Yeah, I mean, Canadarm 2 does have one base point that's technically on the Russian side, but it's barely on the Russian side. So it's like right on the other side of the line. So we can kind of walk over there and reach. And we've been doing that for surveys lately, but like we really can't do much on the Russian side. That's not what our arm is for. So really that's what the ERA is for. But the ERA has only been there for a couple of years. So we'll still see what it can do. It hasn't shown us everything yet. So that's very exciting.
Yeah, Vinita, what's a good example of one of these pre-programmed?
Yeah. So the first 2 missions that are planned for the robotic arm, so it's just gone through its validation phase. So we had 5 or so missions to run in the brakes and to check the arm and do the full checkout and make sure everything was ready for operations, and that's complete, which is fantastic. And the first 2 missions are so we have to go and the team will have to go and locate the radiator and the airlock for the Norca module. So those were actually launched a few years ago, I believe, on the space shuttle, and they're ready to go. They're around close to beam on the station, so kind of near the cupola. So we have to, the team will have to, the EVA crew members are going to go and prepare those elements for the robotic arm to then reach over and to grapple those and bring those to Norca, and then they will be installed. So those are the first 2 missions of the arm. So I know they started the mission a few weeks ago and they had to complete those, but those are examples of what it will be doing. So really it was designed to install and remove experiment payloads and large elements on board station. And so the airlock is great because you've maybe seen for JAXA, they have a small airlock as well that you can actually use to actually put experiments. If you need to put experiments outside on the station as well, they can actually, the crew can then put these through the airlock, and then they can be moved externally, and then the robotic arm can grapple these and use and put them outside on the space station depending on where they need to go. But similarly, the new airlock for Norca, the crew can actually install experiment payloads, and then those can be actually grappled by the arm and then installed on the outside of the station as well. So it has lots of dualities similar to Canadarm, but that's, I think, a new element for the Russian side of the station. But also similar to the arm, it will hopefully transport crew members around the station as well. Right now on the station, before ERA was launched, for cosmonauts, we're using something kind of similar to the joists that knights use. So it's 2 long, kind of pointy, long, I guess, joists that they use, and they were actually using those, and they were deployed, and they're kind of enable them to reach further out onto different parts of the station and modules they needed to reach too. So right now, instead of using that, we'll have the arm that will be able to transport the crew members safely around the station, which will be an improvement. And they're also able to operate the arm from outside during EVAs as well, which gives you a lot more flexibility in the operations.
Very cool. Das, are you piling up some questions?
I have so many questions piled up already. Everything from the electrical and hydraulic requirements of the arms down to things that are going on to Gateway to how much could the arm lift if it was in gravity, like on the surface of the Earth versus in microgravity up on the space station. So I'm just going to start asking some questions. Folks, if you got questions, keep putting them into chat for us, but let's start off with this. Do we know the answer of this? How much mass could the Canadarm2, I guess weight really, could the Canadarm2 handle on the Earth? Like, is it really designed to just sort of move things around, or is it designed to hold things up, right? I guess that would be for Danielle.
On Earth, it cannot support its own weight.
Wow.
When it was tested, it kind of had to be like all supported, and yeah, it's really meant to operate in microgravity. It can't do anything on the Earth.
No,
but in space, it was actually built to move things as heavy as a space shuttle.
No kidding. So on the Earth, it can't even hold up its own. Like if you wanted to test it, you have to have little tethers like holding up the weight for it as it moved around. But in space, it could move the mass of the space shuttle?
Yes.
No kidding. I was like, oh, and in space, it can move the mass of a Dragon or a Cygnus or whatever, but space shuttle's even more than that. No kidding. That was a great question from John. John, y'all, thank you for the good questions here. Let's get some more of them. How often do the robotics arms have to be serviced? Do you like bring them in and you have to, do a lube job and clean them up and replace servos or anything like that? Or what do you have to do to keep Canadarm2 working?
Okay, so for Canadarm2, let's bear in mind that it was put on station in April of 2001. So it's been there almost 22 years.
22.
Everything that we put on space station is meant to, you basically swap out parts, what we call ORUs or on-orbit replaceable units. So far, we've had to change out like one of the arm joints. We've had to change both end effectors because they were just old, basically.
It's wore down.
There's wire bundles that are basically what we use to grab base points and things. Well, those get older over time. So we had to basically change out both ends about, 5-6 years ago?
Yeah.
Other than that, we've had to change out some cameras. In fact, we're planning to change 2, hopefully over the next year. I mean, things get old. If you look, very few of us have a car that's 22 years old that's still on the road. So, they're mechanical parts.
Gotcha.
They degrade over time.
But it's not like, oh, yeah, once a month an astronaut has to go out there with an oil can, like, squeeze, 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 and, add oil to it or anything, right?
Nope. They're supposed to be parts that don't need maintenance.
Gotcha. And Vinita, is there anything that was added to the European arm that would make it last longer, based on lessons learned elsewhere or like that sort of thing?
Yeah, that's a good question. So we were fortunate, I think, because of the delays in the arm, there were upgrades that we were able to do before it was launched to hopefully extend its life. And so I think those upgrades will help it to not need to be serviced as soon as maybe the Canadarm did when it was launched. So I think that's really good because we have those upgrades in place, and maybe the software upgrades that we could do. The actual functionality and hardware of the arm wasn't changed, I think, largely from its original design. But I think with the additional testing that we're able to do allowed us to really predict its operations on orbit. And I think to the current day, it's actually operated just as we thought it would, which is great to see. So we haven't really been able to need to do any updates, I think, at the present moment. I think in terms of lessons learned, I think the ability to be operated through EVA, I think, is unique. And I think that will be, I think, a great ability to have on board station. So we have a crew member that it not only gives you, I think, another backup to operations, because you have an IV, so an internal crew member can actually operate the arm using a laptop. Is what they use for the robotic arm, but it can also be operated in the contingency operations by a crew member during EVA. So I think that's something that maybe was learned from Canadarm and is able to be implemented for the robotic arm as well. And I know it's a slightly different way of grappling as well to the Canadarm too. So I think maybe those are the two main things.
Very cool. It's something you think about, like you don't need somebody out there that's working on all the time, and we're always improving what we're doing. We send one thing and we learn from it. It's like, oh, the material that was made of, or the way that it turned a corner or whatever it is caused more wear and tear, so we're going to change it a little bit this way. And Canadarm has the end effectors with the wire system that sort of constricts down and grabs thing, and then the European arm is different in just ways that we improve what we're doing. It's so interesting because we have to go and we have to do these things so that we can learn from them, but that's what we do. We send something to space, and it's really good, and it does a good job, but there's always something for us to learn, and then the next one we send is a little better. Next one we send is a little better. So let's see here. Here's a good question. Can the arm do multiple pre-programmed steps? And of course, I jump to thinking like the arm, like walking across the station, like, and you just hit one button and it does that. Or is it one step, stop, check everything? Okay, one step, stop, check everything. Danielle, first.
It's more one step, stop, check everything. We have been for the past 5 years working on some, I would say it's a scripting engine. It's on board and we can load scripts to it.
Right.
But we're still in the infancy of actually using it to do like multiple, like a sequence of maneuvers. So maybe we'll get there someday, but at this point we're still manually send where you need it to go. Let it go there, verify it's the right place, and then send the next one.
Gotcha. Vinita, how about the European arm?
Yeah, so I think the European arm is pre-programmed, so we can upload different auto sequences, is what it's called, and there can be a few auto sequences in a mission. So, for example, a mission to install the radiator or a new airlock, or any of the validation missions initially, and so those are pre-programmed. So the actual movement of the arm has been simulated on ground and so that's been tested using the path planning software that we use. And then those steps are pre-programmed in a mission, and we test those missions using the simulator on ground prior to the actual operations. And then any new missions or any new auto sequences that we tested can be then uploaded to the station and then to the crew, and then the crew can then operate those. So it is step by step, but it's been tested on ground. But there is a manual mode as well. So for example, when we need to do any precision operations or to install for the airlock, for example, there'll be a point that you'll see when they install it, and you can watch it on the ground. I'll definitely be watching, and when we actually have crew members that are going to be during EVA are going to be watching the airlock and actually being installed to the station, and that's because it's such a precise operation with like millimeters of distance that we need the crew members to observe at the same time. And during that operation, because the airlock will be grappled by ERA, so ERA will be installing the airlock onto the NORCOM module. That's an example maybe of a manual operation where it is step by step, and you can do that, and so you can change the speed of ERA or the position, and there are ways to also manually operating it depending on what you need. So if there's an emergency or something for a reason we need to abandon operations, there isn't the ability to use manual operations as well to the crew, and they don't have to follow the auto sequences of the mission that was developed beforehand.
Makes sense. So like a piece of space junk is hurtling at the station, and they can use the arm to like bat it away manually. I'm kidding. That's not a thing. That's not a use case for any of the arms. So I've got tons and tons more questions here, but Summer, let me send it back to you for a second, and I'll get a couple more questions in the queue here, and I'll hop back when I'm ready.
That sounds good. I was going to ask you both, what kind of programming language do you use to create these algorithms and pre-programmed motions for the arms?
I mean, for us, it's not really a programming language. We basically just build commands, or we have a command server, within NASA that allows us to basically build the commands that we need and send them. So it's not a programming language per se. It's just like picking out the right commands. We can script them together and things like that. But yeah, it's not really programming per se.
Yeah, similar with ERA. So I think the initial step, and probably similar to Canadarm too, is that you have the mission to develop. So you do initially get an Excel spreadsheet and plan the mission out and plan each move of the arm. And then that goes into the predefined the software that we use to then program the arm. And that's going through the path planning software. And then you can actually simulate it using the simulator that they have. So kind of similar to the arm there. So that's the steps involved.
The fact that you said Excel makes me think that I just change careers now and start working towards here, because I do use Excel a lot. Speaking of what Doss mentioned about swatting debris, it's not exactly the same, but Danielle, before we started, we found out that there was a particular piece of debris returning to Earth that you were involved with. Can you tell us about that?
Yeah, I just found out about this last night. Apparently, Friday night, there was basically this debris that was seen in the sky across Northern California, and it turned out to be a piece of space station called ICS that we jettisoned in February 2020, and I'm the one that pulled the trigger to jettison it. So that's a little bit my fireball that was in the Northern California sky.
I feel like we should name it after you, but I love that years ago you set this all in motion, essentially.
Yes.
What is that component that you called it?
It was called ICS. It was a communication hardware, just testing some type of communication. And yeah, they basically used it, and then they were, wanting to get rid of it. So we just jettisoned it using the Canadarm 2. Right, we do that once in a while. It's not that frequent, but we do some jettisons once in a while.
I think it was this one, right? The ICS, the communication package.
Exactly.
Excellent.
Doss, it says 300 kilograms.
Oh yeah, 310 kilograms. Yeah.
All right, so that made that lovely light show that just happened. Congratulations, Danielle.
Oh, thank you.
Should get like a T-shirt that says like I created a meteor reentry or something, and all I got was this lousy T-shirt or something like that.
Yeah, I'm sure I can make one up.
Yeah, I mean, I'm not sure how many people can locate exactly what they caused in the sky, other than like the giant things that an entire team did. Very cool. So, Vinita, what are you up to these days since you were formally working on the robotic arm? What have you?
Yeah. So these days, I'm a founder of a platform called Rocket Women, which inspires the next generation to study STEM. And I also work at Mission Control in Ottawa, Canada, where I'm based as a project manager. So Mission Control is a space exploration and robotics company. It's focused on mission operations, on onboard autonomy, and also developing AI and robotics for planetary science and robotics missions. So everything to allow you to command and monitor remote assets from the Earth, the Moon, and eventually Mars, and also streamlining operations for robotics payloads on Earth during analog missions, for example, but also in space as well. That's what I'm working on now.
Yeah, are there some arms that are on analog missions here on Earth right now, robotic arms being used?
I believe so. I'm not involved in them per se, more the operations side, but yes, I believe we are.
And are you involved or either directly or tangentially with planning for future robotic arms that may be designed for Gateway?
I'm not involved in Gateway at the moment, but when I was previously based at the European Space Agency, that was definitely a focus of the team that I was working with. So right now, ESA are developing the sample collection arm, and then also there's two modules, the iHab and also the ESPRI. So Gateway is actually going to enable sustainable exploration, which is really exciting in the moon, while also enabling research and also demonstrating these technologies as well before we then go on to Mars. So ESPRI, I believe, is the European system for providing refueling, infrastructure, and telecommunications. And so it has a communications for Gateway, refueling capability, and also a window that's similar to the Kepler Observatory on the International Space Station. So I was involved with the team that was looking at an airlock for Gateway when I was based at ESA, but I haven't worked on it since then. But it's really exciting, I think, to look to the future and see what we have to come, and also just how inspiring that's going to be for the next generation.
Yeah, and just thinking about all the things that we learned from Canadarm that went into ERA, and now all the things that we'll learn from ERA that will probably go into these arms that in the planetary exploration and returning to the moon.
Yes, absolutely.
What do you think what's the coolest thing about working in space robotics for both of you? Like, what do you love most about it?
I think my favorite thing about working in the space industry is just how international it is. I think I've been really fortunate to have worked in multiple countries around the world. And I think even working at ESA, I think the team for the robotic arm was composed of 10 or even 12 nationalities all working together. And I think, like we mentioned it before, I think by going to the International Space University, one of I think the greatest things that I learned was intercultural communication. And that's really been key throughout, I think, every single job that I've done in the space industry, as well as just understanding how the work ethic is, or how just communication differs between different cultures, and just how you work together to work on something as complex as a mission for a space station, a robotic arm for the space station, that you need to really have that understanding. But also you get to work with amazing, incredible people that are really passionate about the space industry. And I think everybody comes to work with that great attitude and great mentality to work on these exciting projects.
Well said. What about you, Danielle?
Well, for my side, what I really love is that there's always something new to develop, some new kind of operation. Like, it's not like, well, we've been doing it for 20 years, we know it all, we can just like reuse something we did last year. No, there's always something new coming up, some kind of operation we're asked to do that we've never done before, some new problem that we need to figure out. So there's never a dull moment. We always have to be creative. We always have to, give a little more energy to what we're trying to do, to try to find the right answer to today's problem. So that's something that really keeps it interesting, even though I've been doing this for 25 years.
And I just to add, I think to that, I think really looking at robotics as well, it's really thinking about how we can use the technologies that we develop for space missions and bring those technologies back down to Earth as well. I think that's really exciting. I think that's also that's really something to think about if you're considering a career in the space industry, is looking at engineering. Look at the impact that you can really have on humanity with a career in the industry. I think there isn't another career that I can think of that has such a global impact and an immediate impact, such as science and engineering. And an example is robotic arm that you might develop, and then that same technology can be used, like I think for Canadarm, a lot of the technology can be used for robotic arms that they use for surgery, for example. And there are lots of great examples of technologies that we've developed in the space industry that are now being used on Earth today. And we're doing that, I think, in Canada as well, looking at Canada's north and looking at how can we improve communications, for example, and also medical technology and improve medical care for communities in Canada and also globally in remote places. That's a really good analog compared to what the astronauts will need to use when they're on Gateway and also on the lunar surface.
Yeah, that's such a good point. And it is kind of amazing how much of the stuff that we develop for space can be applicable in so many different types of areas here.
Yeah, absolutely.
We ready for some more questions?
I'm back.
All right. I have, like I said, there are questions of all types here, but I want to ask this one because it's another thing that's sort of important to talk about when you're talking about robotic arms, right? There's this thing called inverse kinematics, right? And to boil it down for people watching, think about how you move your hand, right? Like if you move your hand and you go to grab a water bottle or whatever, I happen to have a water bottle here to grab. Do you think like, okay, I need to bend my elbow like this, then I need to rotate my shoulder like this, then I need to move my wrist like this? Do you think about all those individual things, or do you just move your hand where your hand needs to be, right? So the question is that how the robotic arms work? Are you telling, okay, the elbow needs to move 5 degrees or whatever? Are you saying, all right, I need the end to end up here. Math, do the job and tell all the different pieces what they need to do in order to end up where the hand needs to be. How does it work for Canadarm 2?
Well, we can do either of those things. We can actually say, okay, end effector, I want you to move to this area in space where the computers will figure out how to move each one of the joints. Or we can say, hey, each joint, this is the basically the joint angle I want you to move to, and then it'll move. So it depends on what we're doing. When we want to like reconfigure the arm in space to go do a new task, usually we do it by telling different joint angles, because we're setting up the arm in a certain configuration to then be able to just like move in and out. And that at that point we'll be basically sending coordinates that will, have the computer figure out the inverse kinematics.
Yeah, coordinates for the end of it. You want the end to go forward, a half meter or whatever, versus all the individual commands. So you can do either one. How about the ERA?
It's similar. I think Danielle answered the question perfectly. So exactly the same, yes. Yeah, so we can also pre-program it. So we have those missions, but also manually it can be operated on board if there is a contingency or for precise operations as well.
Yeah, just like folks, like think about this. Like look at your arm, and if you rotate your arm, I guess I'm rotating my shoulder there. Like your hand moves too, right? So if you want your hand to stay in this water bottle holding orientation, but you want your arm to move around like this, like all the wacky things that your muscles and joints are doing, I'm not doing a very good job of holding this very stable, but the lid is saying sort of up, and just think about all the wacky motions, the computation that has to happen just to keep this water bottle stable. And if you're trying to move forward and grab a spacecraft or something like that, you don't want the wrist going all over the place as you try to reach in and grab that little grapple point. You need it to stay one way and everything else just to do its job, right? So both of the arms can work in both ways. You can either tell the end, hey, end, you need to go like this, you need to end up here, you need to maintain this orientation, or you can fine-tune it by telling each independent joint to do some specific thing, right?
Yeah, and that's also really important when we look at operations that involve crew members. So if there's a crew member on EVA or doing a spacewalk, we need to also have that planned. And also the EVA, when we train, so one of my jobs was also working with the cosmonaut instructors and looking at designing the EVAs that the cosmonauts will have to do and the astronauts do on the space station during each mission for the Roboticom. And that was also really fun because my background is in spaceship design and also spacewalk operations, so that was a dream for me. But we also got to look at where do the crew members need to be, and there's different keep out zones as well on the space station that we need to avoid, but also to tell the crew that there are keep out zones on the Roboticom. So you look at, there's also radiators that they can see on the model here. There's like little mirrors here. So
yep.
Keep out zone and different parts of the robotic arm, such as the end effectors. So there's also lots of rules during EVAs that the crew members need to know, and distances from the arm that they need to be, and also when they can get closer. So for example, if there's a airlock docking operation, they need to observe. But yeah, that's also a good point.
Gotcha. I was bringing up the diagram there that shows all of the different pieces, and there are parts of the arm you don't want the astronaut to like grab onto the arm or touch certain things or bump certain things, I guess, right?
Right. Yeah, absolutely. Especially the delicate bits. So the radiators, for example, they're an example of something that the crew members have to stay away from and not touch because they're just so delicate, and they and also when the arm is grappling, for example, or in operations, that they have to stay a certain distance from as well.
Right, because you don't want it to grapple the astronaut's arm instead of the thing that would be a bad day in space.
Very bad.
Let's see here. Here's a question from Gary real quick, asking if there's any plans to develop something other than the wire grabber. So the Canadarm 2 has the end effector that actually sort of, I don't even know if I could draw it anymore. I was looking to see if I had an animation for how it works, but it's wires that sort of tighten and grab onto something, right? But
Yes.
that's sort of how it works. Like the wires just tighten up and grab by tightening, right?
Yeah, it's basically there's three different wires.
Yeah.
And there's basically a ring that one of the wires will kind of turn and they'll just go and grab onto like a grapple pin.
Right.
So this is a design that we got from Canadarm 1. That's what was on Canadarm 1.
Okay.
We used it in Canadarm 2. Like I mentioned earlier, we've now had to change out both ends of Canadarm 2 because those wires were degrading, which is why we're going with a different design for Canadarm 3 on Gateway. So those wires are out. We're not having those anymore because they're good if you have an arm that's going to come back and get refurbished a lot. But with Canadarm 2, at some point, it degrades. And if you want something that we don't need to change out after 10, 12, 15 years, then we're going to have something that doesn't have those wires.
Yeah. It's a pretty good track record for it to last 10, 12, 15 years in space. Like you really didn't miss the mark there. But you said the grappling is different on the European arm. How is it different? It's not using wires or
it's not using wires, so it's like a mechanical grappling. So it has petals on the end. And you might have an image of, so we have a lab at Aztec that has, so there is originally an engineering model of the arm, which was a full size engineering model, and it was on a flat floor. So because, as Danielle mentioned as well, the arm can't really carry its weight on and when it's in gravity, we actually had it as like an air-bearing floor, so it kind of floats.
Yep.
So we can still send the commands and test the arm and test different translations and movements of the arm and different operations, but it's kind of like gliding along on the floor. And we then used that model and took it apart basically and redeveloped something called an iron bird, which you might be familiar with. It's kind of in the aerospace industry as well. So we can then, it's a smaller version of this that has, we can test proximity operations and grappling, but also movements of different joints of the arm when we do the operations as well. So that's, if you ever have the chance to go to the ESTEC, which is the European Space Agency's Technology Center,
Yep.
You can see the lab there and you can see the model. It's kind of in glass where we work with a team works in the lab, so you can see directly into the operations that they're doing. And you can actually see the end effector of the arm there as well. So it kind of has latches, so it doesn't have the wires. So it has a laser that's used as well, and a target on each base point or on the payload that it's grappling. And so we can use that for proximity operations to approach. And then it kind of latches mechanically using petals, I guess that's the best way to describe them, to the base point.
Gotcha. I wish I had known. I was at ESTEC a couple weeks ago playing video games, actually. I was playing Kerbal Space Program 2, and they brought us out there, and they walked us around some of the labs and stuff, but I don't remember seeing that one specifically. I was literally just there a couple weeks ago. So let's see here. I was looking for the image, but I couldn't find an image of really the end effector up close over here. I saw some lab models and stuff like that, but I couldn't find anything that showed like the detailed mechanics of it. But it's mechanical things that move. It's not a wire that tightens. It's like a mechanical.
The model doesn't really show it, but it's got kind of got the three. You can see the three dots there.
Yep.
Like latches latch onto the base point.
Okay. Let's see here. Here's really quickly. Some people came through with actually gifted some memberships over here. Screen name. Thank you so much for the gifted memberships. And then there was another question from James Williams. How are you having to plan differently, or as engineers, as controllers, do you think that we'll have to plan differently for operating an arm in low Earth orbit, where the space station is, versus operating an arm on Gateway out near the moon? Like, is the time delay that different that it would be a big deal? Or, Danielle, you're shaking your head yes, so.
Yes, I mean, I am somewhat involved in planning for Canadarm 3 on Gateway. And yeah, we are trying to get a lot more autonomy out of our system so that we can basically load up a mission plan. And Gateway is actually supposed to have some amount of autonomy so that it can decide when to kick off different tasks with different systems.
Right.
So it would just be able to kick it off when it thinks it's the right time, and we wouldn't have to be involved. Now, I don't think we're going to get there the first day on Gateway, but that's actually what the ultimate plan is for Gateway, to mostly be an autonomous space station with all of the different systems being autonomous.
Okay.
And so it's very interesting. But yeah, we're thinking that for Gateway, the right solution is not to just be there from the ground and send one command at a time. It doesn't seem to be the right thing to do for something that's that far and that's going to have some kind of time delay.
Gotcha. How about you, Vinita? Do you see any challenges when you get more of a time delay, or should you push more of the processing onto the arm or the station? Or
Yeah, absolutely. There's definitely a time delay. I think one of the really great projects that I'm working on right now is outreach project, but it involves looking at the new Canadarm for Gateway as well. So we're looking at how to inspire the next generation and to consider a career in STEM by using a Gateway as well. So giving them an inquiry-based learning activity using real robotics and real hardware. And we have a mock-up of like a mini part of Gateway, and also a robotic arm that they can use and they can operate kind of using the software that we developed, the operations software at Mission Control. So that's going to educate the public, but also teachers and students about Canadarm 3 as well. And there's lots of different things that we need to look at. And Danielle's mentioned a lot of these as well, which are really important. So it's going to be highly autonomous system. It's going to use really cutting edge software to perform tasks. And that's really going to be the case. And that autonomy is crucial to operations going in the future for lunar exploration for the crew as well. But it's going to be human tended, and that's really different to space station, which humans have been on board for close to 20 years now. So it's people are always there, and something goes wrong, we have crew on board to fix that, and that's not going to be the case. The Gateway, it's going to be tended, and it's going to be very far away. It's going to take days to get there, so it's a really great test bed before we go on to living on the moon for longer periods of time and then go to Mars to develop those technologies. It's really a bedrock of technology development there. It's going to be highly autonomous as well. So we're kind of using that example to inspire the next generation as well, and giving them a way to operate, teaching them how they could operate Gateway or an example to Gateway, and maybe creating the next generation of kind of operators as well through doing that. Also, because we're going to have limited bandwidth, it's going to be really far away. We're going to have shorter communication windows to space station right now, which I think it's 8 hours per week. Daniel probably knows better, so it's very, very short. And any time that you need to update the software, so you have a really short window to really download any data that you need from Gateway, but also to upload any updates, any software updates that you have as well, but also the inability to really view any operations and any damage or any issues. So I think robotic arms really going to be essential and really going to be those eyes that we have on Gateway to view and really inspect Gateway, and have those kind of real-time operations as well. So that autonomy it's really crucial going forward.
Gotcha. It's just, again, I'm never going to run out of questions here. We'll ask questions for hours and hours. I've got tons of questions about AI and computer vision and that sort of thing. And so current arms and future arms, are they using any sort of like CV, computer vision, where it's identifying things and it's zeroing itself in on something because its own camera is looking at it and adjusting itself? Or is that a plan for the future, like a more autonomous sort of thing? Where are we starting with that? Like, where are we with that right now, Danielle?
Okay, so as far as computer vision, I talked a little bit about our autonomy engine, our scripting engine that we have on board.
Yep.
It does have some amount of computer vision, but I'm not going to say that it's perfect. It does still have issues. We're working on it. We also have a computer vision system on the ground that will take downlink video. And that one's actually quite stable. It very much helps us to align when we're grabbing something with Canadarm 2, but especially with Dexter, because Dexter's 2 hands, we do also need to grab things with those. And it's actually kind of difficult to get aligned, especially in depth. So that computer vision system on the ground really helps us to basically not miss, because we were known to miss quite a bit prior to getting that system. So we really like that system.
I brought up the image of Dexter, and it's like, imagine getting this aligned correctly, right?
Yes. Yes. So it has 2 hands, and it goes and grabs very small fixtures where we have to be really precise. And the depth is not really easy to see, but that computer vision system can interpret it better than we can. So we're grateful.
Gotcha. How about a European arm or other things, Vinita?
Yes, the European arm, I don't believe has computer vision presently, but it is, as Daniel mentioned, really important for the future, especially if we need to include that autonomy and we have such limited communication bandwidth and also windows to actually perform any operations. So I think machine learning based automation will be, I think, helpful to monitoring the operational state of the new Canadarm on Gateway, and also the gateway itself, and also health monitoring. So if anything goes wrong, it'll need to know that itself. It'll need to find that out and then send the ground the information during those communication windows. So any data analysis, but also predictions as well. I think we need to look at how to predict and detect any failures. So looking at the data, and we need to maybe do that on the ground as well, looking at the data that we already have and learn from the arms that we have on station. Look at how can we maybe predict any failures that might occur on board for Gateway, and how to prevent that as well, and maintain that and support that in the future when we have those challenges for Gateway.
Gotcha. Summer, I'm going to hop over here. Like, I don't want to be like, oh, let me go and look at new questions while y'all are talking, right? So y'all talk about the next topic, and I'll find some more questions.
Well, actually, I kind of wanted to talk more about the Canadarm 3 that's in the works. And Danielle, if you could tell us more about like what state that's in at the moment. And you mentioned that you're not using the wires. So what are you using?
Well, okay, so for Canadarm 3 that's going to be on Gateway, I would say that in some ways we're still in the design phase. We have a fairly good, basic idea, but it's for what's going to replace the wire. It's basically we're going to be, I don't know how to describe it, but we're going to go in and then kind of like rotate to click into something.
Kind of like those things, furniture.
Yes.
Yes.
The cams.
Yeah.
Yes.
Okay.
So that's how we're getting away from the wires. It's more of we're going to click into what we're trying to grab.
Yeah. Okay. That's interesting. So, and is it going to be, is it still, I mean, you're still planning and designing, but roughly the same size? It's going to have a slightly different, I would imagine, requirements, being at such a different location.
Yeah, it's going to be a little smaller, but then again, it's going on a smaller space station, so maybe that goes together. But yeah, it's going to be smaller. It's not going to have a second robot called Dexter that we're going to maneuver around. It might have a smaller arm, but that's not completely sure yet. There's decisions still being made with exactly which pieces, because, we're engineers. When we start designing things, there's going to be 1,000 things and 1,000 tools. And now we're going, okay, this is going to cost a lot of money. Which tools do we actually need on here? So we're at that phase of the process right now.
Right. Yeah. Well, so speaking of the planning for that, but the Canada 2 arm is still being operated. What is like your typical day or typical week look like? Are you kind of splitting your time between these things? Are you still in mission control?
Okay, so for my part, I would say that doing space station operations is like 98% preparation, 2% execution. So Fair. We do have operations every week, but we have a large team. So I'm not doing operations every week. So yeah, most of the day it's just trying to plan different things. Like I'm currently planning for the next Japanese cargo vehicle. They're redesigning the cargo vehicle that goes to space station, and it's one of those vehicles that gets captured by Canadarm2 when it arrives. So, I'm one of the ones that's spending a fair amount of hours just planning for that new vehicle. And there's different things, camera change out. So we do a lot of planning ahead of time. And yeah, we do have the candy at the end that we get to sit in mission control and actually do the things that we've planned.
Yeah. Vinita, in your current endeavors, do you have a daily/weekly routine of any kind? Like what kind of things are you just doing on a daily basis? What kind of activities or calculations or designing or planning?
So I guess I'll talk about being a European robotic arm, as I was an operations engineer. So I'm based at ESTEX. You'd come in and then I have sometimes it'd be a week of training. So Danielle's probably also familiar with this, but you have the instructors from GCTC, which is in Moscow, which is where the cosmonauts are trained. So they would come to Aztec and we would train them. And we'd have translators, so you have to kind of learn how to work with a translator, and that's something that's quite common in the space industry because there's just so many languages involved as well. So present the technical information, any updates for the arm. We train the instructors in the lab, so we have so the hardware that we have is the IMI, which is the internal operations for the arm, which is a laptop basically that we use to operate it, but also the external. It's called the ME, or the EVA, man-machine interface is what it's called. So we actually operate it externally as well, and a screen. And so they've learned how to operate those, and also go through the missions. And if there are any updates and any new things they need to learn, we teach the instructors during the week, but also we'd have regular meetings with the team. So my job was also to liaise with our Russian counterparts, because it was a joint mission between ESA and the Russian Space Agency as well, because it's on the Russian part of the station. It was launched on Norka, which is a new Russian module. So it's working with them quite closely to really train the cosmonauts, working on the spacewalk design with regards to the robotic arm, but also I'd work on the education aspects as well. So I also work with the European Space Agency's education outreach team to develop new materials that they can use about the robotic arm. They can then use to go into schools, and also for teacher training as well. Apart from also spending time in the lab, so actually developing the missions and testing the missions. We test them multiple times before they're actually then uploaded to station. So we actually have them, they were uploaded, I think, initially when the robotic arm was launched, we had them there, and the first few tasks were really to install the arm. So that there were multiple EVAs that were planned, that the crew then carried out to actually run in the brakes, for example, and do a checkout of the entire arm and the systems, and to install the IMI, which is the internal interface that they use to control the arm, and also the external interface. So there's multiple things they have to do, but I think the really test of the arm, the really exciting part, is really me to use it and to actually do these new missions. So the radiator and airlock mission, but also just like what is there to come as well with the robotic arms? How can it be used? I think inspecting the station as well, because it's been in orbit for such a long time, that is crucial, and we do have that capability and improved, and then in HD quality as well with the upgrades that we've made to the robotic arm as well. So I think that'll be really interesting to see, and it might have actually already been used with the issues that there were with the Soyuz and the Progress vehicles on board, to look at how we can use robotic arms on board to really protect any failures and to really mitigate and support those.
Yeah. Oh, very cool. This might be a silly question, but because you have the separate sections of the station and then you have the two different arms, are the astronauts cross-trained on them for backups or?
So for the robotic arm, the Russian cosmonauts are trained, and also I know select ESA members are usually trained. So ESA crew are trained depending on the flight manifest as well as to who is planned to be operating the arm. If we have any missions planned for the increments that they're going to be on board for. So I know the ESA crew members are usually trained, and Russian cosmonauts as well.
But on both arms, or just on the European arm?
I think Danielle Cormier speaks for the Canadarm, but for the European arm, it's mainly Russian.
Yeah, so for Canadarm 2, we mostly trained basically Americans, Canadians, Europeans, Japanese, but we have trained select cosmonauts in the last few years, just because we didn't know with the vehicle traffic if we were going to end up in a place where on space station there would be nobody there that can operate Canadarm2 at a certain time. So that's something they have to take into consideration, that there's always that knowledge on board space station. So we did train a few cosmonauts recently, just to be able to allow for that flexibility.
Okay, yeah, because I was just thinking, I feel like NASA's contingency planning as well, backups. And so you wouldn't want to get in a situation where you needed to use an arm and then there was no one who knew how to use that particular arm at that time.
Yes.
Not ideal. All right, Doss, are you coming back in, or can I ask one?
I have more questions, of course. Do you have one more you want to ask?
Well, just to get it in before we have to end and cut everything off, I wanted to ask Vinita just a bit more about the Rocket Women work that you're doing.
Yeah, absolutely. So I think as I was going along my career journey, I noticed over the years, so from finishing my engineering degree to then starting to work in the industry, like as I progressed at each step, the number of women that progressed with me to ultimately choose a career in engineering decreased. And I think if you look at the numbers, in the UK, only around 12% of the engineering workforce is female, and only around 9% of that of engineering professionals are from a minority ethnic background as well. And in the US, it's around 16%. And I think in Canada, if you look at the space industry, it's less than 30% of the entire industry identify as female. So I think the goal of Rocket Women and the passion of the work that I do is really to reverse this trend, and also to empower young women to consider a career in STEM and really encourage them to do that, and also support them throughout their career journey. It's really seeing somebody like you, I believe, is also really empowering, but also allows you to believe and that it's possible to achieve your goal in the future. But I think the lack of, gender and racial diversity in STEM that we see, and especially in the space sector, is really not only an issue of inequality, but also I think that's going to affect the engineering that we do and also the systems that we create. And I think we also need to enable the STEM industry and the space industry as a whole to really reflect more of society, to prevent any biases as well from being implemented. So those are really important, from everything from spacesuit design to developing new AI to be used on the moon, and also facial recognition algorithms. So all these really, really important things that are going to be crucial to our lives in the future. I think we need to make sure that the creators and developers of these systems represent the range of backgrounds and also cultures and experiences of the diverse users that will use them, and the public that will be, informed by them, and also they'll experience them on a day-to-day basis. And I think the last few years, have shown us that we really need 100% of the talent out there to really solve those really hard problems that we see in the world today as well. So that's really the crux of the work that we do. We also have a scholarship program as well. So we raise funds through our apparel purchases. All the funds go towards a scholarship for women in engineering, and that goes currently to the International Space University through a scholarship there to help for young women, to support them to study at the master's program. So there are lots of things that we do to try and encourage the next generation, to support them and inspire them, but also to make sure they can make sure we have increased diversity and make sure everybody has the same opportunity to go along that journey and choose a career in engineering and in science.
Fantastic. I'm so glad this, and I also recognize at least 3 of the people in those photos. So that
Okay.
Now, see, just real quick, I brought up the Rocket Women website. It's just rocket-women.com. That's the right website, right?
That's right.
Okay, good. So if you want to learn more, you can go. We'll get a link over in the chat. Just go to rocket-women, like rocket-women.com, and there's all sorts of more information. You can contact or reach out, that sort of thing. So if you're watching at home and you're interested in learning more, maybe make sure you check out the website. And I wanted to say really quickly, I keep getting messages like this. Vinita and Danielle. Lauren says, just a massive thank you to today's guests, their time and patience in trying to explain all this stuff to us. We've actually got John here who said, please thank Danielle and Vinita. My little one has been watching, and seeing women in their position is extremely exciting for her. So
amazing.
I've got more and more messages like that coming in. People just saying thank you for being inspiring. Thank you for being on the show and just showing what you do. Just thank you. I can't say it any better than that. Let's see here. I do have more questions. Back into some technical style questions. Are there any contingency plans for if the arm has grabbed something and it loses hold of it while it's moving it around or something? I imagine there's a notebook that has like step 1, step 3, step 162. Danielle, how about you?
Our work is full of contingency plans. That is a big part of the job. So yes, we have generic contingency plans. We have contingency plans for a certain operation. And yes, I often joke that a big part of my job is to just be paranoid that everything's going to go bad all the time. And to basically always have this internal story going, okay, if this goes bad, I'm going to do this. If this goes bad, I'm going to do this. It's actually part of being a flight controller, and that's how they train you. They train you in simulations where everything does go wrong.
Right.
So, and we're able to actually react when it happens in real life.
And it does. Sometimes it does go wrong. You need to be able to react. Having that communication is crucial, really.
Yes.
Can I ask?
Sometimes it does happen.
Like the specifics, like say you're in the simulator theoretically, and the end effector becomes loose, and the payload is no longer attached to the end. Like, what do? Do you try to hug it with the arm, or what could you possibly do? If I can ask that.
Well, hopefully we'd be able to regain control of it before we actually completely lose it.
Right.
And there's, our system is made so that other than a really bad mechanical failure, we shouldn't lose control of it.
Right.
But yeah, that's basically all we can do. In the case of, a vehicle that arrives at space station that we grab it, it could always float away, or it could always basically fly away.
Right.
If it's still unable to control itself. But those are the kinds of things we have to take into consideration when we're planning an operation.
Gotcha. Say you're attached to a spacecraft and all of a sudden thrusters start firing. That would never happen on the station. That would be something that you would have to deal with.
Yes.
I went down to NASA Johnson, and they put me in the big simulator where they train on the arm operations, and I got to use the little joysticks and stuff. And it was interesting, the different modes that they went through, like you need the spacecraft to station keep here. And now the arm is about to grab it, so the spacecraft needs to give up control and not try to fight against the arm. And there's different modes that the spacecraft and the arm are in as they work together, because you don't want a spacecraft fighting the arm, right?
Exactly. Everything has to be free drift when we grab a vehicle, because otherwise, if a thruster goes off, then you're no longer aligned with the vehicle you're trying to grab.
Yep. Even the station itself, right? Even the station itself doesn't do any corrections, because a little correction on the whole body of the station could be a big correction on the end of, or a big effect on the end of the arm, I guess.
Yeah, exactly.
Yeah. Vinita, how about situations where something gone wrong? Is there an emergency? I imagine a lot of the times it's just stop everything and let's see what's going on. Any more details?
I actually have an image that you can bring up of grappling. You can, so on the robotic arm, in case there is a failure, if we can't operate it, for example,
right,
there is a mechanical override. So an EVA crew member can actually do a spacewalk and actually go out, and you can see this isn't the exact tool, but it's an example of one we use in the lab. So they have a different tool that they use using spacesuit gloves, but this is the exact override that they can go to, so you can actually grapple and ungrapple the arm using that mechanical override. So there's lots of things like that we have built into the arm to provide that. So for example, if we need to grapple over ungrappling, if there is an issue, if it stalls during the grappling, or if there's something that happens during that process, the crew member can go in and actually grapple the arm fully to make sure we're in a safe position before the operation is completed as well. And I know there are different modes that we can put the arm in case that we need, if we can't fully grapple. So if both sides aren't grappled to a base point and there's a visiting vehicle, for example, that is docking to a station, there are different positions that we can put the arm in to make sure those loads are okay for the arm, basically, as it docks.
Gotcha. Thank you so much for that. I've been waiting for the excuse to show these images, and I honestly didn't exactly understand what they were. I was like, why would you ever put a wrench in there and try to turn it manually? But now I understand.
Just in case.
Just in case. So it's like a little picture, and you can even see that it's in I guess that's going to be Cyrillic, like Russian and then English there, the grapple and ungrapple, and which direction to turn it for those things, because like you said, the Russians operate, or the cosmonauts operating that sort of stuff, they could go in there and manually close or open the grapple, huh? All right, very cool. Let's see here. Grabbing more questions. We got about 10 minutes left in the show. I'm not going to run out of questions. How many Canadarms does it take to change a light bulb? Seriously? All right. I'm sure we know the answer to that, because Canadarms use Dexter to replace cameras and things like that. But I don't think it's changing a lot of light bulbs on the outside of the International Space Station.
No, not really. We do have lights incorporated into the cameras that we're gonna change out.
Right. Let's see here. How are the arms powered? So Rick Skinner asked, how are the arms powered? I guess they're mostly electric motors. There's no hydraulics or pumps or fluids or anything like that moving them around, right?
All electric.
All electric. Gotcha. So no like weed whacker motor up there or anything like that. It's all electric motors. The huge solar arrays on the ISS gather electricity. They store it in the station batteries, and then that's used to move electric motors, servos. Are they motors? Are they servos? Is there a cool technical term I should use?
They're motors.
Motors? Okay. I'm not going to feel as cool if I say motors. If there was like some, acronym or something like, oh yeah, those are actually I don't know. I can't make up an acronym on the fly.
They are brushless DC motors.
Brushless DC motors. I have a little RC helicopter that has those. I think my drill has one of those as well. Let's see here. Another question. Can you please have this crew back again and again? This is one of the best NSF lives I've ever seen. So many nice comments coming in, y'all. Thank y'all so much for posting those up for us. Here's one. Okay, I'll ask the question. British Tea Guy asks, have there been any incidents involving the arm where it's ended up like the wacky waving inflatable tube arm man, or gone out of control, or bumped something it's not supposed to bump, or anything that we can talk about?
I mean, we've had some close calls.
Right.
We've never had actual collisions. We've gotten close. There was actually one incident back in 2002 that I was involved in, that it was the astronauts that were in control of the arm, because it was during an EVA, and there was a crew member, a spacewalker at the end of the arm. And they almost hit the arm into the shuttle payload bay door, and we had to do an emergency call to get them to stop.
Really?
Yes.
Just like the context, like one part of the arm, maybe they didn't really see exactly where it was, and they kept moving in a direction and getting closer and closer. And the ground controllers are like, no!
Yeah. They were focusing on the end of the arm, and it was the elbow that was swinging out to hit something.
Oh, wow. No kidding. Anything with the European arm, Vinita, that you're aware of?
No, nothing with the arm. It's still going through validation, so it's completed that, and now it's just started mission. But hopefully it's been tested well enough that we won't have any issues, but everyone's trained just in case there is contingencies. Gotcha.
Was there something with the Canadarm 2 that was like a micrometeoroid strike or a little bit of damage or something like to it? That?
Oh yeah, we have a nice little hole in one of the boom segments that we found. It got hit by a micrometeoroid. We looked at it correctly. They're carbon fiber booms.
Yep.
But there doesn't seem to be much delamination. So from what we can tell, it didn't even lose any strength or anything like that. But I think we got lucky.
Yeah.
Even though we were unlucky to get hit. It didn't cause much damage, so we're happy about that.
Can the arm inspect itself? Like, I imagine it's like trying to, wash your back or something like that. There's some parts that are hard to reach. Can the arm inspect itself? Or is it like they move the arm close to another camera? Or how do you inspect? You send an astronaut out on EVA?
Well, we've done a little bit of all of that. The cameras on the arms are standard definition. They're not great for doing high-def surveys, but there are nowadays high-def cameras on space stations. So when we want to inspect part of the arm, we do just go and basically right in front of the high-def camera and maneuver in front of it to see what we need to see.
Gotcha. I saw that on Twitter. I don't remember where I saw it on Twitter, but there was the leak in the Russian spacecraft, and then there were some really nice photos, like up close of the leak. And somebody tweeted like, "Oh, the arm was used to inspect that." And somebody in ops or control or something responded, "There's no way the arm took that photo. The cameras on the arm itself aren't that high resolution. That had to be another thing." I remember that on Twitter, so that makes sense. The cameras they're just standard definition on the arm, right?
They're standard def, but those cameras were taken from the arm. We actually maneuvered over there.
Really?
Yeah.
No kidding. Okay.
Yeah.
So you did inspect the little leak, the coolant leak or whatever that ended up being on the Soyuz.
Yeah, well, for the Soyuz back in December, we got some really good pictures. For Progress, that happened, last month?
Yep.
We weren't able to get pictures as good because it's in their location on space station, and we just couldn't get there because, like I said, our only base point on the Russian segment is just like barely on the edge of the Russian segment. So we just we the arm wasn't long enough.
Wasn't long enough.
To be any better. Yeah.
Yeah. I want to cover this real quick because this is it's a cool game you can play at home next time you see, the live stream of the astronauts doing the EVA or a vehicle arriving or whatever, right? Be on the lookout for these. So we've been talking about the arm grabbing points. That right there, it's like a little triangle thingy, right? It's almost not quite a nuclear symbol, but it's a little triangle thingy, and it has a little pin sticking up from the middle of it. So when you're looking at pictures of the station, because things are going on, and you're joining NASA TV or whatever, watch for those little points. And let me see, I've got a bigger picture of the station here. Once you realize what those things are, you start to realize that they're all over the station. I hope I don't circle one that's not actually an arm, but there's a little grapple fixture, and there's a grapple fixture somewhere in this area, it looks like, and then there's grapple fixtures up here, and then there's grapple. I mean, these are the points. Actually, is this one the grapple fixture on the transporter?
Okay, that's the transporter. Some of the ones you circled, though,
Yep.
are not base points. They were basically the fixture we used to install that piece on space station, but we cannot go get base there.
Ah, is it like the ones on like the Japanese and European laboratory? Are those base points or those installation points?
They're installation points. So the fixtures that we used when we were assembling the space station.
Gotcha. So did the arm grapple those when it was being assembled, but then you don't get to use those going forwards?
Exactly. But on the little square you did, there's actually 4 there on the mobile days.
Oh, yeah. It looks like there's one sort of in this direction and one in this direction. I don't know if I can zoom in any more on that. Let's see here. It's just so interesting to look at the space station, and that is not zooming in. There you go. That's zooming in. They're like in different angles, it looks like, huh?
Yes, they are. And that's by design so that we can reach different ways to different parts of space station.
Gotcha. I think my pen was a little bit thinner there, but I'd never thought about that. I thought it was just like, oh yeah, there's 4 things there, but there's one sort of angled this direction, one sort of angled this direction, and based on what you're trying to do, you might grab a different one of those base plates. And this is the thing that it's the train you talked about that goes up and down the station, right? The main truss?
Exactly.
And
yeah, where you put the arrows, that's basically where some of the rails are. So it just goes up and down the rail.
Gotcha. All right. Well, just be on the lookout. Like, look for things like that. You'll see it on the visiting vehicle that's going up there to get grappled. This was the time lapse of, I've drawn ears on it. This is the time lapse of a Cygnus being grappled here. And that's the Canadarm 2 and the end effector you can see there. And it's sort of going for that grapple point and stuff. But I've always thought that that's interesting, like the fixtures you see on the station that you can use to sort of move things around. That's cool. Let's see here. Summer, any final questions here? We got like a minute and a half left.
Well, actually, I wanted to know when you were talking about the potential like banging of the elbow of the arm, do you just have like a big red button in mission control that you can just press, or do you really have to just yell at the astronauts through the Capcom to stop everything?
Well, that was one of our first incidents, so it was basically more the yelling part. Nowadays, we do have always the safing command that's, ready to us, so that in addition to yelling, we'll actually send the safing command and save the arm from the ground.
Do both. Oh, good to do both.
That actually seems like a good idea, like big red buttons that are installed everywhere, and if anybody slaps one of those buttons, it like automatically sends a message and sends a command and lights a light or whatever. Like,
well, nowadays it's clicking something on a mouse,
clicking something with the mouse.
Big red button on the screen.
On the screen, nice. Let's see here, y'all. That does look like it's going to bring us to the end of our show today. It's 4:30. We get guests that come on the show and they're like, oh, geez, what are we going to talk about for an hour and a half? Like, I might be able to talk for 20 minutes. And getting so many great questions from the chat just gives us so many different topics to talk about. And I am so happy we had 2 experts who are both experts in operating the arm from the ground and designing arms with your wealth of knowledge here today. Thank you all so much for spending time with us.
Thanks for having us.
Excellent. Let's see here. I am supposed to say what's coming up next. Oh, yeah, I remember the Astro Live things, that whole NASA cooperative agreement awarded to the New York Space Grant Consortium. I actually met people from the New York Space Grant Consortium, cool people, whenever I was out there last month. In the next month's show, we have a show coming up next month. It's not going to be a Zoom show next month. It's actually going to be live on site. So Astronomy Night is happening on April 28th, and we are going to be talking about, more astronauts, I guess. We've got astronaut Nicole Stott, we've got Inspiration 4 astronaut Dr. Cyan Proctor, and Mike Massimino, who are going to be having a little bit of a chat. So next month, April 28th, live from Intrepid Museum. Make sure you tune in to catch that. If you want to learn more, visit intrepidmuseum.org. And remember, the website, Vinita, for your Rocket Women, it was rocket-women.com. Check that out if you'd like to learn more about Vinita's work with rocketwomen.com. It's rocket-women. I keep saying it that way, then people type it in wrong, and then they're like, oh, that's not the right domain. But click the link in chat. We'll see if we can get a link over there in chat. Beyond that, Danielle, Vinita, thank you so much for spending time out of your weekend here to answer all of our wacky questions here. Chat is saying thank you across the board. Thanks for the informative panel. This is one of the best ones I've seen. So much good technical info. Just thank you so much for being here and spending your weekend with us.
Thank you. It was amazing.
Thank you.
Thank you so much.
It's always like, well, thank you, Danielle. Thank you, Vinita. Like, am I supposed to thank you one at a time? Like, thank you both. Just... and always, Summer, thank you as well. It's always a pleasure hanging out here. Again, folks, this is Astro Live. It's a museum that it's a museum. It's a show that Intrepid Museum puts on once a month, and they partner here with NASA Spaceflight to bring it to a little bit wider audience. But we do these on the third weekends of the month. Well, it's actually the Sunday after the third Thursday, but follow on Twitter, right? Intrepid Museum on Twitter. You can follow NASA Spaceflight on Twitter as well. If you're watching one of the channels, like and subscribe or whatever the kids are doing these days. There's like buttons you click and it tells you when the streams go live or whatever. Whichever way it is, if this is the sort of content that you enjoy, we do hope to see you back next time. But I have now kept with my drawn-out outro our guests past the time we're supposed to have you. One more time, Danielle, Vinita, Summer, thank you all so much, and we will see you nerds later. This is when we all wave, and then I press the button to stop the stream. And by the way, we say see you nerds later, like I am proudly a space nerd. Sometimes people in the comments are like, oh, you called him a nerd. You were so rude to him. Like, is it okay if I say nerds to everybody on the call?
Yes.
All right. Good deal. So that's the end of the show, and we will see you nerds later.
Propulsion continues to be normal.
Chamber pressure looks good.
Traveling up. Roger, Atlantic.
Water towers, fly!
Echo Delta nominal.
Flight down, speed off. Bring in, speed off. Off.
Yikes. You bet. Concur. We don't need any more of these.